Hi everybody, today we're going to learn another way to solve a quadratic function. And that is to take the square root of both sides. Now this only works if you can isolate whatever is squared. So it generally doesn't work if you have like x squared and then another x term. You cannot use this method. That's the factoring method. But if all you have is x squared, then you can probably use this method. So the idea is that you have whatever term is squared on one side, and then all the other plain numbers, everything else on the other. When you take the square root of both sides, the square root of x squared is x. Now because we don't know what we're squaring, are we squaring, let's say, the -4 to get to the 16, or are we squaring the +4 to get to the 16, which is a made-up number. I just made that up. But because we don't know, whenever you take the square root, you have to put the plus or minus in front of each answer. All right, so every time you do this, you just throw a little plus or minus sign. You write x equals plus or minus, and then you simplify your answer. So we do have to simplify this radical. 90 is 9 times 10, and then we know the square root of 9, so this will be plus or minus 3, because that's the square root of 9. We do not know the square root of 10, so plus or minus 3 radical 10. So again, the first step is to isolate the squared, so that x squared has to be all by itself. So here we're going to move that 1 over, and now we'll divide both sides by 2. Now we get x squared equals 8. And then, of course, the final step is to take the square root of both sides. Now, if the number under the radical can be simplified, you have to simplify that. So this is the square root of 4 times the square root of 2. So we know the square root of 4 is 2. We do not know this. So it's the plus or minus, of course, 2 square root 2. Again, first thing you do is get this x squared all by itself. So I'm going to subtract 3 from both sides. So we have -5x squared equals -12, and divide by -5. This fraction, of course, cannot be simplified, but we have 12/5. When you take the square root of a fraction, take the square root of the top, take the square root of the bottom, do it all separately so that you remember. So now we're going to have x equals, well, we can't have a radical in the bottom. So then you multiply the top and the bottom by the bottom. So we'll multiply the top and bottom by the square root of 5. So now we get plus or minus, of course, the square root. Now these are both under the square root, so we multiply them together. Square root of 5 times the square root of 5 is just a plain 5. And now we just have to simplify it. So 60 is 6 times 10, 2 times 5, which is 2 times 3, and 2 times 5. So there's a 2 in there, and then the 3 and the 5 stay home. So this is going to be plus or minus 2 square root of 15 over 5. The square root is protecting this 15, and this is just a plain old 5, so they don't go together. You can't simplify that. I'm just trying to show you all the different things you might run into. When you have a fraction, it really doesn't change too much. We have x squared over 25 equals 12. Well, I'm going to put the 12 over 1, and I'm going to cross multiply. That diagonal is x squared. This diagonal is 25 times 12, which is 300. And now, of course, take the square root of both sides. 300 is 100 times 3. So the square root of 100 is 10. We do not know the square root of 3. So you get plus or minus 10 radical 3. Still the same thing. I'm just, again, trying to show you all the weird things that could happen. Here, when we add the 12 to both sides, you get -x squared equals -75. Well, you can multiply both sides by -1. You could divide both sides by -1. But the idea is you can't take the square root of a negative number, so you got to make both sides positive. So now we can take the square root. 75 is 25 times 3. So we can take the square root of 25 out as a 5. Don't know the square root of 3. Now for number 6, again, we have another fraction. But if you look, they both have x squared on the left. So I'm going to get these as one fraction. So the common denominator there is 6. This already has a 6. And if we make this 3 a 6, we've basically multiplied by 2. So we have to multiply the top by 2. And of course, this 72 is just there. We'll get to that in a minute. So now we can actually combine these two fractions. So this is a 6, and 5 minus 2x squared is 3x squared. You can simplify that if you want to, but we can also just go ahead and keep going because it's going to work out fine. So we have 3x squared equals, and then you multiply the other way, and 6 times 72 is 432. Now that's a big number, of course, but we're not going to have to deal with that for too much because we're going to divide by 3 to isolate that x squared. And now we get 144, which this is a perfect square. So the square root of 144 plus or minus 12. Now the style of problem we have left has a quantity squared. So it is this quantity that you're going to sort of try to isolate. So we're going to keep this guy all by itself. So we're going to divide both sides by 3. And so now we have x minus 2 quantity squared equals 7. And you can go ahead and take the square root of both sides. Now when you do that, the power of 2 and the radical sign are gone. The plus or minus goes with the side with the number, not the letter. Now we don't know the square root of 7. So now we got to add 2 to both sides. And when you do that, put that in front of the plus or minus sign because it's kind of a built-in arithmetic problem. So we're left with x equals 2 plus or minus the square root of 7. You do not need to come up with the decimals for that. That's the exact answer. That's how we like it. And that's how it'll stay. You don't have to simplify it. It's finished. So again, the part that we're isolating is the quantity that is squared like that. So that's going to just stay right there. So we're going to add 45. So 2 times a minus 16 squared is equal to 98. Divided by 2. So now we have a minus 16, which is still squared, equals 49. Now we take the square root of both sides. That gets rid of the power. You can even get rid of the parentheses. Square root of 49 plus or minus 7. Now when we add the 16, again, sort of squeeze that in front of the plus or minus. You'll see why we like it in front, because now we have 16 plus and minus 7. You have to actually finish the problem. So you have to do both arithmetic parts. This is 16 plus 7, which is 23. And a also equals 16 minus 7, which is, of course, 9. So these are the answers for that. And finally, when you have a fraction, just go ahead and multiply both sides by the reciprocal. So we multiply this side by 2, multiply this side by 2. That gets rid of the fraction. So we have x plus 8, that's the quantity squared. The other side is 28. So this is the last kind of style for this problem. We're going to take the square root. Now this 28, that is 4 times 7. So you have to simplify the radical. So you get plus or minus 2, because that's the square root of 4, and we leave that 7 underneath there. Now when you subtract the 8, you're going to put it in front of the plus or minus. You can't do any of the arithmetic, but it's kind of a combination of simplifying the radical and the number. And then this is the answer. Again, don't put it in the calculator. We don't want any decimals or anything. So try the homework problems and keep track of any questions you have, and we'll go over those tomorrow.